Hello everyone, you are welcome to C Academy YouTube channel. My name is Veleleni Nkosi. In this lesson we discuss the examination guideline regarding momentum and the impulse. The document that you see on your screen is an examination guideline downloaded from the Department of Basic Education website. In this video I will only discuss momentum and the Newton's second law in terms of momentum. So the other topics, they will have a separate video so that we can avoid very long videos. So without wasting more time, here is the guideline. So due to visibility, I had to copy the information so that everyone can see. I increases the font. So everything that is in the guideline, then I put it in a big font so that even if you are using a very small device, you'll be able to follow me. So examination guideline, momentum and then impulse. So I will start with momentum. The thing that you must be aware of, something that you must know before you sit for an exam. You must be able to define momentum as the product of an object mass and its velocity. You must know this definition by heart, because they might ask you to what is momentum. So you must know that momentum is the product of the object mass and its velocity. So for example, like if I've got this trolley, obviously this trolley has a mass. So if it's stationary like this, momentum is 0. But immediately if it starts to travel, like this, it has a momentum now. So its momentum is the product of the velocity that is traveling at multiplied by the total mass of this trolley. So this is something that you must know. Let me write the formula. Momentum of an object, momentum is represented by P. Momentum of an object is equals to mass of an object multiplied by the velocity that the object is traveling at. So you must know this formula by heart. So this is momentum, it's represented by P. This is the mass, this is the velocity. Then if we go to number 2, something that you must know, you must be able to describe linear momentum as a vector quantity with the same direction as the velocity of the object. So here, like they are telling us that momentum is a vector quantity. Yes, because velocity is a vector quantity. It has a magnitude and the direction. So does momentum. It's a vector quantity. It has a magnitude and a direction. So you must be able to draw a vector of a momentum. And then number 3, you must be able to calculate the momentum of a moving object using P equals to mass times velocity. This is the formula for momentum. So here is the formula. P is equals to mass times V. You must be able to calculate momentum. Let me give you an example here. Let's say this trolley is traveling maybe to our right hand side. V equals to 3 meters per second, and then mass equals to 1000 kg. So they say calculate the total momentum of the object as it travels to the right. Travels by 3 meters per second, and the mass of this car is 1000 kg. So to calculate the momentum, we are going to say mass, then which is 1000 kg multiplied by 3. And then we've got 3000 kg meters per second, because they say momentum is a vector. So you must show the direction. You must show that it's traveling to the left or to the right. So you must always show direction, or downwards or upwards. It depends with the direction that the object is traveling to. Like if it's traveling in this direction, then you will say 3000 kg meters per second to the left. If it's going to the right, then you say 3000 kg meters per second to the right. I hope you understand. So always you must show the direction, because if you want to get all the marks, you must show the direction. And then now we are going to number 4. Number 4, they say describe the vector nature of the momentum and illustrate it with some simple example. So here is what let's say this car is traveling to the right at 3 meters per second, and the mass of this car is 1000 kg. So let's say it's traveling in this direction. So to draw a vector, we know that a vector is something that has a magnitude and is showing the direction. If it travels to the right, our vector is going to be like this. And say 3000 kg meters per second. This is if the trolley is traveling to east or to the right. If it's traveling to the left, then our vector is going to face this direction. And then what do we do? You're going to say 3000 kg meters per second. So you must be able to show the natural vector of a momentum. So if it's going to the right, then this is the vector. If it's going to the left, then this is the vector. So you must be able to differentiate. And always when you calculate momentum, state the direction. Then we are going to number 4. Number 4, it says draw a vector diagrams to illustrate the relationship between the initial momentum, the final momentum, and the change in momentum for each of the cases above. So here we are drawing a vector diagram. You remember in grade 11, we did vectors in 2 dimensions, where we add vectors on a Cartesian plane. Here we are going to use the same method. So let me explain something here. Let's say this is the ball, this is a wall. So someone comes and kick the ball. Then this ball move towards the hole. Then it hit the wall, then moves back. So when it hits this wall, a collision happened here. So to explain, by the time the ball was kicked, it has a momentum. So this momentum, we call it initial momentum. It's Pi. And then when it hit this wall, then there is a collision between the ball and the wall. So the ball goes back. It still has a momentum, but this time the momentum in a different direction. So this momentum, when it goes back, we call it the final momentum. The final momentum. And then in between initial momentum and the final momentum, there is a change in momentum. Remember, the momentum was going to the right hand side. Final momentum is heading to the left hand side. So there was a change in momentum in between. So a change in momentum is written as change in momentum is written as a delta P. This is a change in momentum. And change in momentum is also a vector. So it can be represented as a vector. And then the formula for calculating change in momentum is final momentum minus initial momentum. This is the formula for calculating change in momentum. So because we want to work with vectors, when we work with vectors, we use addition. So if I take initial momentum to the other side, I will end up with here change in momentum plus initial momentum equals to final momentum. This is the final momentum. So change in momentum plus initial momentum equals to the final momentum. So that is mean if you add this, because we said change in momentum is a vector and then momentum is also a vector, initial momentum is a vector. When we add vectors, we end up with resultant. So that is mean when you add change in momentum and initial momentum, then they give you final momentum. The final momentum is the resultant of change in momentum and the initial momentum. So now we are going to draw a vector diagram where in a situation where this ball is bouncing on the wall. Let's say now we can see it practical. Someone kicks this ball. This ball takes this direction. Then we draw a vector for initial momentum. This is the initial momentum. And then when we draw a vector diagram, we use head to tail method addition. So now we have to show change in momentum, because this ball, by the time after it hit this wall, takes the opposite direction. So when we draw change in momentum, it's going to start at the head of the initial momentum. Then change in momentum is taking this direction. Let me change the color here. This is change in momentum. And then final momentum is the resultant of change in momentum and initial momentum. So final momentum start at the tail of the first vector and then end at the head of the last vector. So that is mean the final momentum is going to be something like this one. This is P final. Let me change the color so that you will be able to see. This is the final momentum. So it started with, because final momentum is the ball is taking this direction. So initial momentum, the ball was going to the right, and then final momentum, the ball is heading to the left. So this is the change in momentum. Change in momentum always start at the head of the initial momentum, then to the head of the final momentum. This is the situation when if the ball is bouncing. Let's say the ball, maybe someone kick it, maybe there is a glass or a window here, the ball passes through the wall and then come to the other side. So we have to draw the vector diagram in a situation like this. So to draw a vector diagram, we also going to start the same with this one. We have an initial momentum, and then this is initial momentum, and then when the ball hit this glass, this ball change the speed. Obviously some momentum will be lost on the glass. So change in momentum is not going to be as big as this one, because the direction of the ball is still the same as the direction of the initial momentum, of the initial speed. So that means changing momentum fail to cancel the initial momentum. So that is mean maybe we can say, because it has to start at the head of the initial momentum, then the changing momentum, maybe we can say it's here, maybe, because it didn't cancel the initial momentum. So here, this one we can say changing momentum. Let me change the color so that you'll be able to see. And then now we have to show the final momentum. So final momentum, we say start at the beginning, at the tail of the first vector to the head of the last vector. So that is mean final momentum will start here and then goes to the head of the changing momentum. Remember, the ball passes here and is still taking the same direction as the initial momentum. So here is the same as PF. This is the P1, changing momentum, final momentum. Always changing momentum is in between the heads of the initial momentum and the final momentum, always. So this question is very rare to appear in an exam, but sometimes, because it's written on the guideline, it might appear. They say draw a vector diagram showing the relationships. So we must be able to show the relationships. Even if the speed of the ball is increased, you must be able to draw the vector diagram. And now we are done with momentum. And then we are going to Newton's second law in terms of momentum. So what we must know about the Newton's second law in terms of momentum, we need to state Newton's second law of motion in terms of momentum. So the law says the net or resultant force acting on an object is equals to the rate of the change of momentum of an object in the direction of the net force. So let me show you this law in practice. Let's say we've got this ball. Someone kicks this ball, then this ball travels towards the wall. Then the ball hits the wall, then moves back. So that formula, that law said the net force between the wall and the ball, F net, is equals to change in momentum over change in time, because it talks about the rate. Here it says the net force acting on an object is equals to the rate of change of momentum. So the rate is it talks about time of changing of momentum of the object in the direction of the net force. So this is the formula that I've showed you here, like option number 2. They say you must express Newton's second law of motion in symbol. In symbol is F net equals to changing momentum over changing time. Then what happened? If we kick this ball, obviously the ball travels the first or initial momentum. Then this ball hits here. As it hits this soil, there is time here. The time that it spent before it moves back is this time. And then there is this ball, when it moves back, there is a force that this ball exerts on the wall and there is a force that this soul exerts on the ball. So that force is this net force. And then change in momentum is the initial momentum and the final momentum. So T is the time that this ball spent with the wall. F net is the force that this soul exerts on the ball. And then change in momentum is the initial momentum and the final momentum. So be able to interpret this one. Then this is the law that they're talking about. Then if we go, they say we must explain the relationship between the net force and the change in momentum for variety of motion. The net force and the change in momentum are always in the same direction all the time. If net force is negative, change in momentum is going to take the negative sign. If it's positive, then it's going to take positive sign all the time. That is the relationship. So the relationship between the net force and the change in momentum is always in the same direction. Then here they said we must calculate the change in momentum when the resultant force act on an object and its velocity is increasing the direction of the motion, is decreasing, is reversing. So the formula for calculating the change in momentum equals to, and then we can say mass times V for final minus mass times V for initial. So because the mass will remain the same, so we can say change in momentum is mass into final speed minus initial speed. Therefore, M is equals to, this is the formula that most of the people are using. So this is the mass, this is the change in V. So if you want to calculate the change in momentum, then we're gonna use this formula. So thank you for watching this video to this far. I appreciate that. Thank you. Good luck with your exams.